Imagine that you're an astronomer in the year 185. As you gaze upon the numerous constellations, you realize that one star has increased in size. This star continues to burn with increased size and luminosity for months, before eventually the star disappears entirely without a trace. This event left astronomers puzzled, wondering what else is there about stars that we don't know. Fast forward to today, we know that this account is the first recorded supernova. While we are still not completely sure of the mechanisms of supernova and dying stars, we have a pretty good idea of how these celestial bodies help shape the universe that we know today. Being the building blocks of all galaxies as well as the catalyst to the creation of new elements, stars hold an ever-important place in our cosmic narrative. Today we will journey from the formation of the universe's first stars all the way to the final breaths of the last. Stars shine as some of the most enchanting and diverse characters in the universe. These celestial luminaries come in 4 different types, each with its unique story and personality. The first of these 4 types is the red dwarf. Red dwarfs are the tiniest stars in the universe. Imagine stars the size of Jupiter, but much hotter and brighter. They may be small, but they're incredibly long-lived, burning steadily for billions of years. Their dim glow makes them difficult to see from afar, but they dominate the stellar stage, constituting around 70 to 80% of all stars in the universe. Next, we have the yellow dwarf star, which is the same type as our sun. These stars are middle of the road in terms of size and longevity. They shine with a steady, warm radiance, making their orbits perfect cosmic dwellings for planets like Earth. The rock star of the different types of stars is the blue giant. These are the dazzling, massive stars that burn fiercely, often a million times brighter than our sun. Their brilliance is matched only by their short-lived existence. Their formation is a dramatic process marked by immense gas clouds collapsing under gravitational pressure. Yet, their intense energy output pushes them to the cosmic edge, leading to rapid lives and fiery deaths. The final and most intimidating type of all stars is the supergiant. Picture stars so immense that our entire solar system could fit within their boundaries. These are the supergiants. Their formation often involves the interplay of complex cosmic processes, leading to the birth of these colossal masses. Now that we have explored the different types of stars the universe has to offer, let's explore the full life of a star. In the vast expanse of the universe, where the dark fabric of space stretches beyond imagination, there exists a cosmic dance that has been unfolding for billions of years. It's a dance that lights up the night sky, sparking our curiosity and wonder. This is the story of how stars are born, a story that takes us to the very heart of the cosmos. But before we delve into the enchanting tale of a star birth, we must first cast our gaze back to a time before stars existed. In the early universe, only a few 100 million years after the Big Bang, the cosmos was an immense dark void with the building blocks of creation scattered throughout. There were no stars, no galaxies, just a soup of primordial matter. Within this vast sea of matter, tiny ripples formed, much like ripples on the surface of a tranquil pond. These ripples were gravitational fluctuations, the seeds of cosmic structure. Over eons, these fluctuations grew in magnitude, pulling matter towards their centers. Slowly, but surely, gravity began to extend its reach. As the matter gathered into denser regions, it heated up and created the first faint glimmers of light. These were not stars as we know them today, but rather the precursors. These protostars slowly became more and more massive, gradually gathering the material into compact regions, where it becomes denser and hotter. As the density and temperature continue to rise, the pressure at the core becomes intense, and nuclear fusion ignites. This is the moment when a star is born. The radiant fusion of hydrogen atoms into helium unleashes an unimaginable amount of energy, lighting up the darkness of space. In the midst of all the nuclear fusion comes the formation of new elements which help shape life and the universe as we know it. Before the arrival of stars, the universe consisted of hydrogen, helium, and small traces of lithium, bringing the grand total of all elements to 3. With the formation of stars, we add another 11 elements. The process by which stars are able to create these new elements is called stellar nucleosynthesis. Beginning with hydrogen, a star can use one element as fuel while simultaneously creating a new element through nuclear fusion in its core. This process repeats for billions and billions of years, going through each of the elements all the way until silicon. While the first stars were undergoing nucleosynthesis, they completely contained all of their matter, still hiding their secret elements from the rest of the universe. And it would be much later, at the end of the star's life, where all the new elements formed inside of their cores would finally be cast out into the farthest reaches of the cosmos. As we all know, the periodic table does not stop at silicon. However, it is at this point that the star loses its ability to hold itself together. At this stage of its life, the star has grown to such a massive scale that the gravity of its core cannot reach the outermost layers. For stars that are similar or smaller than our Sun, the outer layers slowly escape the star, destroying all orbiting bodies, leading to the creation of new planetary nebula. Nebula are cosmic nurseries, places where stellar matter is spread into clouds of gas and dust. These nurseries are scattered throughout our galaxy and many other galaxies in the universe. And in these colossal clouds of gas and dust, gravity once again plays the leading role, enabling the formation of new stars and galaxies. However, for stars that are at least 5 times more massive than the Sun, they are able to repeat the nucleosynthesis process all the way until iron is present in their cores. Unfortunately, at this point, these stars meet the same fate. But for larger stars, losing their outer layers creates a sudden change in both mass and pressure. This causes the structure of the entire star to collapse, leading to a supernova explosion. And in the supernova explosion lies the key to the creation of all the other elements in the universe. As a massive star collapses, the core is able to increase in temperature by up to 50% due to the decrease in pressure. And in this extreme heat begins many thermonuclear explosion reactions. These reactions are violent and release absurd amounts of energy in the form of a supernova. With the death of the giant stars, heavier elements such as gold and uranium are finally sent flying throughout the universe. Now that we have explored the enduring life of a star, we can begin to understand how they are the true foundation of the universe we know today. However, just as with everything else in the universe, these celestial beacons will eventually meet their fate. But what if I told you that that isn't the case for every star? Scientists have observed some stars explode multiple times into supernova. This is possible because in a binary system, a white dwarf left in the center of a supernova explosion can use its gravity to steal hydrogen from its neighbor star. By feasting on the living, these zombie stars gain the presence of hydrogen, which allows them to ignite the nuclear fusion process, starting their lives once again. As remarkable as an ever-living star may seem, it is believed that this can only be obtained by a star which belonged to a binary system and collapses into a type 1A supernova. While the existence of zombie stars leave astronomers puzzled, we have a lot more evidence about the afterlife of regular stars. When a star dies, there are 3 potential outcomes. As mentioned before, a planetary nebula is produced upon the death of stars that are similar or smaller than the Sun. After the star has completely expended its stellar matter, a dim glowing body remains at its core. This body is called a white dwarf. White dwarfs are mere shadows of the celestial giants they once were. Immediately after forming, white dwarfs are extremely hot, but without sufficient fuel and mass, they are unable to partake in nuclear fusion. Because of this, over time, these bodies will cool off and crystallize, forming the theorized black dwarf. It is believed that the cooling process takes longer than the current age of the universe, meaning that there are currently no black dwarfs in existence. However, scientists believe that this could be used as evidence towards the universe's limited age. Although this fate is much less exciting than that of much larger stars, around 97% of the stars in the Milky Way, including the Sun, will all eventually end up as black dwarfs. For medium and large-sized stars, we go back to the supernova. However, there are actually 2 additional potential outcomes of a supernova. The cores of stars with 10 to 25 times the mass of the Sun will compact with great force, forming a neutron star. These spooky remnant stars form due to an excess of metal in a star, causing its collapse to compress it past white dwarf density. This intense density forces all of the protons and electrons in the star to combine, leaving almost entirely neutrons, giving it its name. Neutron stars are the smallest and most dense of all the stellar objects. While it could be just 6 miles in diameter, a neutron star of this size could weigh up to 1.5 suns. Both the gravitational and magnetic fields of a neutron star are hundreds of billions of times stronger than that of Earth. And to make things even crazier, they spin on their axis hundreds of times per second. The fastest spinning neutron star ever discovered rotates over 700 times per second. This is equivalent to about 24% the speed of light. These high speeds cause the neutron star to eject hot stellar matter from its core out through both of its poles. The result objects known as pulsars, which are the brightest objects in the universe. Along with all of the matter being ejected from the core, pulsars send out radio waves in very consistent intervals. So consistent, in fact, that when scientists first discovered them, they believed it was messages being sent by extraterrestrial life. As time goes on, the rotation of a pulsar slows down, until after around 10 million years, it runs out of stellar matter and returns to being a regular neutron star. Left behind in the enormous supernova of massive stars over 25 times larger than the Sun are some of the darkest and most mysterious objects in the universe, black holes. Black holes are celestial behemoths that boast some of the greatest densities and masses ever found in the observable universe. These massive cosmic structures are made up of two different parts, the singularity and the event horizon. The event horizon marks spherical boundaries of the black hole that is often referred to as the point of no return. It is at this point where the escape velocity required to escape the gravity of a black hole is greater than the speed of light, allowing it to trap every possible thing in the universe, causing it to infinitely fall towards the singularity of the black hole. The singularity is the center of mass of the black hole, and it is believed that once you reach the singularity, the laws of physics as we know them start to break down. It is at this point, a point that is both infinitely small and infinitely dense, that the biggest mysteries of the universe begin to come to light. Black holes come in all shapes and sizes, from primordial black holes to supermassive ones. Supermassive black holes often sit in the center of galaxies, Sagittarius A star being the supermassive black hole at the center of the Milky Way galaxy. There are a lot of misconceptions surrounding black holes. There are two that we are going to explain today which can really help to understand their true nature. Many people believe that black holes suck everything, including light, in towards their singularity, but the truth is, black holes behave much like any other massive object. If you replaced our sun with a black hole of similar mass, the gravitational effect on the Earth would remain the exact same. We would just miss out on all of the heat and temperature provided by a star. With that being said, many people also believe that galaxies orbit around a black hole much like our planet orbits the sun. The reason this is not true is because while the sun accounts for over 99% of the mass of our solar system, a black hole consists of less than 1% of its galaxy's mass. While they are the most massive objects known in the universe, they still are not massive enough to gravitationally bind an entire galaxy. Scientists believe the real reason for galaxy formation falls into the responsibilities of dark matter. Unlike white dwarfs and neutron stars, when a star collapses and meets the fate of becoming a black hole, they are reincarnated into something oftentimes much more powerful than ever before. Now that we have explored the origins of many stellar objects in the universe, as well as the life cycle of stars, we hope that you understand how stars facilitated the creation of the universe as we know it. If you enjoyed the video, please make sure to leave a like and subscribe. Leave a comment down below letting us know if you learned anything in this video. While everything we know was once part of a star in the earliest stages of the universe, it is incredible to think about the scale of these celestial campfires. From the centers of our solar systems to the centers of galaxies, there is no doubt that stars and their descendants hold a significant spot in the structure of our universe. As knowledge grows and we begin to unveil the truths of these stellar luminaries, we might find that stars themselves lie in the center of the universe.